The type of current used by a transformer must be large, small, direct, or AC. So, if we think about how a transformer works, it works by turning an alternating electric field into a different alternating electric field, or one voltage into another voltage. And for that to happen, the field needs to be changing, otherwise there's no way for it to transmit the signal over a magnetic field. So large and small don't really make much of a difference. If it's direct, it can't work at all. And so our correct answer must be AC, alternating current. Question 4. A neon sign requires a 6,000 volt supply for its operation. A transformer allows the neon sign to operate from a 240 volt supply. See why transformers are useful? So what's the ratio of the number of secondary turns to the number of primary turns for the transformer? So in this case, we're trying to turn a small voltage into a big voltage. So that means that the secondary turns to the primary turns will be big to small. And we can see from the ratio of 6,000 to 240 that the correct answer will be 25 to 1. Question 5. What is the function of the slip rings on an AC motor, or in fact an AC generator, if you want to build it like that? We have a few options here to change the direction of the supply current, to provide electrical contact, to provide a constant magnitude of torque, or to change the direction of the torque on the coil. Now, as it turns out, because we can run an AC motor on an AC power supply, we don't ever need to change the direction of the current, because the AC power supply will do that automatically for us. So we don't have to worry about changing the direction of the supply current or changing the direction of the torque. Constant magnitude of the torque doesn't really work for any motors, because when it's in the wrong place in its rotation, then there'll never be any torque when it's halfway through. So we can rule out C as well. Our last option then is B, to provide electrical contacts between the coil and the external circuit. In fact, if we had a ring that was completely fixed to the coil, then the coil wouldn't be able to turn. So the purpose of slip rings is simply to allow the coil to connect to the circuit without getting tangled up along the way. Question 6. An electric motor is being used to lift the engine out of a car, which correctly identifies the useful energy transformations that occur. So of course we have to start off with electrical, because we have an electrical motor. And what will we end up with? Well, we're lifting up an engine, so it means that we'll end up with potential energy that's gravitational. So that means that we can rule out D. D would be a case where something with gravitational potential energy suddenly began falling, and we ended up with kinetic energy. So our three options here are electric kinetic heat, electric kinetic, or electric sound. Now, we can assume that the motor doesn't make noise and use that noise to do work, so we can rule out C. And our last options now are electric to kinetic to heat, or electric to kinetic. Now, both of these seem pretty tempting. We know that when we transfer energy, there's always a little bit of heat or energy lost during the transfer. So that makes A seem pretty attractive, except heat only comes out once. But in fact, this heat isn't what's transferred into gravitational potential energy. Heat that's lost during the conversion is in fact lost. It doesn't continue the chain. So our correct answer is in fact B, electric to kinetic to gravitational potential. And in every step of the way, you're getting a little bit of heat coming out, and a little bit of heat coming out. But as I said, this doesn't continue the chain of energy translations. It's important to remember that while everything does produce waste heat, that waste heat never does any work.